Hi, my name is Daniel Demalum, and this is the UNPACKED 555 timer project. The NE555 is a versatile chip that is being used as an astable multivibrator to provide a continuous clock signal. The frequency of this oscillation is controlled by external resistors and a capacitor connected to the IC. The math following the frequency of this oscillation is F equals 1.44 divided by R1 plus 2R2 times C. By adjusting these components, you can control the timing and frequency of the output signal. Additionally, if you use a potentiometer, you can control the frequency of the oscillation by wiring it as a variable resistor. The unpacked up version of the 555 IC shows what's inside this chip. Firstly, there are three 5 kilo ohm resistors which form a voltage divider, creating reference points of 1/3 and 2/3 of the supply voltage. These reference points determine the timing for when the capacitor charges and discharges. The LM358 dual op-amp chip IC houses two comparators, which compare the voltage across the timing capacitor to the 1/3 and 2/3 thresholds. When the capacitor voltage reaches 2/3 of the supply voltage, the first comparator triggers the SR latch, turning off the output and starting the discharge phase. When the capacitor voltage drops to 1/3 of the supply voltage, it triggers the other comparator, resetting the latch and restarting the cycle. The capacitor's discharge is managed by a transistor, which, when activated, provides a path for the capacitor drain to ground, resetting the timing cycle. In this case, I've used the clock output of the unpacked 555 timer as the input to a shift register, which displays its data on a 7-segment display. These LEDs are a simpler visualization of the bits that are stored in the shift register, with this being bit 0, this being bit 7, for a total of 8 bits. On my 7-segment display, I have it watched with the outputs 0 through 7, follow the order of 0, 1, 2, 3, 4, 5, 6, and 7. The frequency of the clock signal can be seen through this LED. When this LED turns on, a high signal goes to the shift register, shifting in a bit of data. When this button, the data button, is pressed, it allows the shift register to receive the data being shifted. When the latch button is pressed, whatever data is stored in the shift register is displayed onto the 7-segment display. In short, if this data button is pressed and this signal goes high, it shifts in a bit of data. If it is not pressed and this bit goes high, it shifts in a 0. Using this, you can control what the shift register outputs on the 7-segment display by combining the usage of the data and latch manual inputs. This has been the 555 Unpacked Timer. My name is Daniel Demalum. Thank you for listening.